Hey, this is the 2013 multiple choice. Some solutions for you. I'm going to do it right on here. I don't have a lot of extra paper right at hand. I apologize for my voice is a little scratchy. I have a little bit of a cold, but probably over it by the time you're watching this video, so don't shed a tear for me. All right, let's get started. Questions 1 through 3. We have an object mass 10 kilograms, starts from rest at time 0, moves in a straight line from time t greater than 0. The object's velocity as a function of time is given by this. Oh, this looks like calculus waiting to happen, where v is in meters per second and t is in seconds. How far does the object travel during the first 10 seconds of its motion? Well, that's a little fundamental theorem of calculus. That would be the how far does it travel. So let's see. Displacement is this antiderivative. I'm only pausing. I'm just wondering if there's any turnarounds. When they say how far does the object travel, we just have to check and factor this. I think that there aren't any places where it turns around in the positive, but we could check. There aren't any questions about that. So let me just real quick. If I were doing this, if I were taking this test, I think I would probably feel compelled to do this and then say, okay, so the turnaround points are at time 0. So that doesn't matter for us because that's where we're starting, and at t at negative 2/3, sorry. So that doesn't matter for us. So it's only moving in the forward direction. That's good. All right, so that means the displacement, total distance traveled are the same. So antiderivatives, t squared plus t cubed from 0 to 10. That's 1,000. Plus 100 minus 0. That's D. All right, calculus right off the bat. I love it. What is the instantaneous net force that acts on the object? Well, if to get from velocity to force, we could take the derivative of this. That gives us acceleration. And then if I multiply the entire thing times mass, then mass times acceleration is force, and the mass is 10, so it's 10 plus 60t. And then if I plug 2 into that, I get 120 plus... Did I mess something up there? Oh, that's 20, isn't it? Sorry, I did. What's this? Right? Get from acceleration to force, just multiply by the mass. How much work is done by the net force between time 0 and time 1? Well, if there's no other force acting on this, then work done by this force is equal to the change in its kinetic energy. So from time 1 to time 2, I have, let's see, the velocity, the change in kinetic energy, that's K final, so 1/2 times mass times V final squared minus 1/2 times 10 times V initial squared. And the initial velocity is 0, so that's all 0. Its final velocity here at time 1 would be 5, so that's 1/2 times 5 squared, which, oh sorry, I doing things in my head and getting ahead of myself. 1/2 times 10, which is 5. So that's 125 joules. So there's our relationships there. Good stuff. Number 4, persons X, Y, and Z walk along a circular path of radius 50 meters. Person X, did they start at the same place? Halfway around the path. Oh, okay, so it doesn't matter where they start. We're interested in the magnitudes of their displacement vectors taken. Let's just have them all start at the same place. So let's say they start here, and here's a circular track. So person X walks halfway around the track. So they're here now. That's their displacement vector. Person Y walks 3/4 of the way around the track. So that's their displacement vector. You notice right away that that is smaller than that one. And person Z walks all the way around the track. So the magnitude of their displacement vector is 0. So it looks like we have, this is 0, and then this is whatever that is. And that's, X is the biggest one. Yeah. This, if you chose this answer, I think that you should, I mean, obviously you can look at this and be like, oh, I see, that's why. But if you put these in order, you're like, okay, let's see, X walks halfway around, so that's half, and then this is 3/4, and then this is all the way. You have to catch yourself there and think that like this, the right answer to this question cannot possibly be put the fractions 1/2, 3/4, and 1 in order. Like that cannot be it. Like if you find yourself doing that, immediately you need to second guess, I think, and say, wait, that's not right. That's too like not physics, right? All right, 5. A small particle starts from rest from the origin of an xy coordinate system and travels in the xy plane. Its acceleration in the x direction is this, and its acceleration in the y direction is this. What's the x coordinate of the particle when its y coordinate is 12? All right, let's see if we can do this. This is like calculus-y too, it seems like. Small particle starts, so it starts from rest at the origin. So I think this when its y coordinate is 12. So here, this means the y coordinate is equal to 1/2. It's got constant acceleration, so in the y direction, 1/2 a t squared plus vit plus initial position, but those are all 0, so the position is just given by this. And so I'd like to know what time is that equal to 12. So let's see, when that's equal to 12, looks like t would be equal to the square root of 24. Interesting. So x, same deal, 1/2 a t squared plus vit, but the initial velocity is 0, plus initial position, but the initial position is also at the origin, so that's 0. So I want to know where it is, and now I know what time to plug in, right? So it looks like it's at position 24, because those cancel out, and then square root of 24 squared is 24. That's answer choice D. And number 6, if the speed of a moving object in a straight line is increasing at a constant rate, so the speed is increasing at a constant rate, that means constant acceleration, which means constant force. Then the net force acting on the object is constant, but not 0. That was easy. Don't go missing questions like that. Let's see, what are we at? 8 minutes for this one? I suppose we could stop this video there and we'll continue. So this is 2013 numbers 1 through 6 in this first video.